let f of x equal the greatest integer less than x plus the greatest integer less than negative x. For what values of a does the limit as x approach a of f of x exist? And at what numbers is f discontinuous? I think the best way to do this will be to plot the function f and just identify places where it jumps or places where it's not continuous. It should be pretty clear what the greatest integer less than x looks like as a function, and the greatest integer less than negative x looks like as a function, but the sum I'm not completely sure. What's the easiest way to plot this? I think maybe just by substituting in several values of x and seeing what kind of pattern we get that we can extend. And this will probably be easier to do for like non-integer values of x. So maybe I'll make a table. I'll make a table of values first, and then just kind of fill in the blank spots for the function on the plot itself. So it's pretty clear that at least for values of x which are, let me figure out what this is at 0.5. So this will be 0 plus -1 is -1. So for positive values of x which are not integers, the function will be equal to -1. What if x is an integer? Interesting. So at the integers, at the positive integers, it's equal to 0. And in the intermediate places, it's equal to -1, like this. And so on. F of 0 is clearly 0. What about for negative values of x? It'll be the same, right? When x is equal to -0.5, we'll have -1 plus 0, which is -1. -1.5, this will give -2 plus 1, which is -1. Yeah, I think this pattern sort of just extends for all real values of x. So in fact, this function in general can be written as 0 if x is an integer and -1 if x is not an integer. So to answer the question itself, the limit as x approaches a of f of x, this is equal to -1 for all values of a, and f is continuous for all x not an integer. We see that from the figure. As long as x, the function jumps, maybe I should have plotted the function in a different color. I'll do it like this. The function's equal to -1 everywhere except at the integers where it jumps up to 0. So for values of x that are integers, the function is discontinuous. So I've written this the other way. F is discontinuous at the integers. So this was a nice one. I didn't really know. I didn't really know off the top of my head what this function was going to look like, and so that's what I just figured plotting it would be the best approach. And in fact, plotting it wasn't even the easiest thing ever. I know based on the way the function is defined, it's almost certainly going to be piecewise continuous or piecewise constant over some intervals. And so that's why I figured just making a table of values and then extending the pattern from there would be the best way. If I have more to say about this, I'll write something down in the description. Thanks for watching.